Alright. Scientific notation. Most people seem to think that they know this until their homework ready. So, number 1, right in scientific notation. $8,391,005. Rule number 1. There can be only one number left of the decimal, not 0. What is it, not 0? 0 can't be the number left of the decimal when you're writing in scientific notation. Really, only one digit can be left of the decimal. Right now, the decimal's right there. There are 7 numbers left of the decimal. There can only be one number left of the decimal. And it can't be 0. So, rule 2. Must be multiplied by a power of 10. So you have 2 things for something to be in scientific notation. There can only be one digit left of the decimal, it can't be 0, and it has to be multiplied by 10. If you have that, then it's in scientific notation. It may look like it's in scientific notation if you have something else, but it has to meet these 2 rules. Understand? Alright, good. So, if the decimal's here, where should it be? Minute. Okay, between what? 8. Between the 8 and the 3. So, it should be 8.391005, and you will write all the numbers. That's rule number 1. Rule number 2, I have to multiply by 10. Why am I multiplying by 10 at this point? This is the key to your exponent. Okay? So those of you who think you're good at this, better make sure you understand this. Why in the world would I multiply this number, not that one, this number by 10, Cameron?
Because you're moving it a tenth of a place when you move the decimal over.
Yeah, this 10 is going to move this decimal, not that one. Because if I was moving that decimal, I'd multiply this by a power of 10, wouldn't I? If I multiply this number by a power of 10, this decimal would be affected, right? But I'm not multiplying this one by a power of 10. I'm multiplying this one. Do you all understand? I'm multiplying this number by 10. So this 10 is affecting this decimal, isn't it? Not this one. Stop looking at this number. I want to know what this decimal needs to do for this number and that number to be equal. That is the most important thing that you can take from this. So what does this decimal need to do in order for this to be equal to that number? What? Yes?
Move 6 places.
Move 6 places. Yes. Which direction?
To the right.
To the right. Why is it moving to the right? Yeah.
Because when you move to the right, it gets bigger, and it needs to be bigger to match it.
That's right. This decimal needs to move to the right. Not that one. Have I made it clear? Okay, so this 10 affects this decimal. And since you're moving it to the right, is that positive or negative? Right is always positive. Left is always negative. That's why this is a positive 6. Because this 10 is moving this decimal. Don't look up here and say, well, it moved left 6, so that's negative 6. Okay? Don't look at the problem. That's extremely important that you understand this. Those of you who think you're really good at this. I don't want a bunch of people missing the problems because they thought, well, I moved that one, so it's negative and it's really positive. All right. Enough said. Example 2. You make the mistake now, it's your own fault. 0.008034 times 10 to the 8 is, first of all, the question I need to ask you is that in scientific notation?
No. No. Yes.
No.
Bryn,
No.
she says no. Who says no? Who says yes? You're all fired. Bryn is correct.
Yes.
Why is Bryn correct, Luke?
Because it should be 8.034 to the,
Well, that I don't need to know. Why is this not correct? Because you said it. The decimal's not in the right position.
yeah.
There's a 0 left of your decimal. You can't have 0 left of your decimal.
Ha, is what you got.
Okay? Good job, Bryn.
Oh yeah, Brent told him too.
Yeah. So, what I really want to happen here is I want this to be put in standard form. Okay? So, how do I put this in standard form? Now that you understand what the power of 10 does to that decimal in that problem.
Move the decimal over to the exponent. However many exponents there is.
Which direction? And how do you know?
Right.
Why?
Because,
It's my favorite lesson to teach. Not really. Why am I going right?
because then it's going to be a bigger number. Because the exponent is negative.
Because the exponent is positive. The exponent's positive. That means this was positive. What did that do to this decimal?
Go to the right.
It meant that this decimal was going to move to the right. So if I want this in standard form, then I really need to take this number times that, which means I'm moving this decimal 8 units to the right. So 1, 2, 3, 4, 5, 6. How many more?
2.
So 2 more zeros. That's how you do that. Okay. Now almost everybody has no problem with this. But for some reason, when we have to do this, everybody's like, what? Let's make this. Example 3. Let's make it difficult.
Let's not.
3.2 times 10 to the third. Is that scientific notation?
Yep.
Yes.
Awesome.
Well,
Oh, boy.
yes, there's more.
Yeah, there's more. What do you want to do with that? Let's multiply this scientific notated number by another scientific notated number.
Oh.
I don't see you.
No,
I know what you do.
Okay, first of all, is it all multiplication?
Yep.
Do I really need the parentheses then?
No.
Can I rearrange multiplication?
Yes.
So why not just take 3.2 times 4.67 times 10 to the third times 10 to the negative 5? Doesn't that sound like a better thing to do?
Yes.
Not really.
Oh, it's not that difficult.
Why would I want to do that?
Because then you have the decimals on one side and then the scientific, the other part on the other side.
Okay.
So you can eliminate the 10 to the third.
Well, not eliminate, but combine
Yeah.
your like bases. So what is this right here?
10 to the negative second.
Yeah. All right, so somebody on your calculator tell me what 3.2 times 4.67 is.
14.
Lauren.
14.9.
Yay, we're done.
No.
Why not?
It's not
Non-scientific notation.
Thank you. What isn't in scientific notation specifically, Luke?
There's 2 digits left on the one side.
The number is not in scientific notation. The power of 10 is fine. Okay? So here's where students make their mistakes. You need to make this in scientific notation and then multiply it by -2, 10 to the -2. So here's your new number, just like what we had over here. Given a number, put it in scientific notation. So here's your number. Put this number in scientific notation. So rule number 1, where's the decimal go?
After the first
Somebody
number.
knew. Where's the decimal go? Somebody knew.
Uh-huh.
Yes. After the 1. Right here.
No.
Between,
Between the 1 and the 4.
thank you, between 1 and 4. That's what you need. Okay, well that number isn't the same as that number. So what do I gotta do?
Change 10.
Rule number 2, multiply by 10. Now what's my exponent need to be? What does this 10 do to that decimal? What does this 10 do to that decimal? What does this decimal need to do to equal that one, Sarah? Which, to the right? So, what goes here? Well, you said 1 to the right.
Yeah, but doesn't the 10 go over 1?
Yeah, I'm just trying to get you to say that. Obviously, you don't need to write the one, but now you understand. Okay, are we done?
No.
Why not?
Gotta multiply 10 to the first one.
Yeah, these two can go together, can't they?
Sure why
What's 1 plus -2?
Negative 1.
One. I feel so smart.
Are we done?
Yes.
not? We are.
No, with scientific notation
Oh, yeah.
on the 10s.
Downstairs.
Okay? Because that's the key part about this, so we keep our numbers small. Alright? So we're talking about, millions and billions of miles away from the sun and how fast light travels. Instead of using these really long numbers, we use scientific notation numbers.
Yeah.
We're talking about DNA and microscopic measurements and how small those numbers are. We use scientific notation. All right, so let's make it harder. Example 4. What?
Nothing.
3.78 times 10 to the -8. Yes, men, there's more.
Dang, no.
Is that scientific notation?
Yes.
Doesn't really matter at this point.
No.
No.
Divided.
7.045
It's
times
not
10
hard.
squared. It's what?
It's not hard. I've already done
Well, gosh, it's Stephanie can do it.
it. Oh, that's.
Oh, this is gonna be on international.
That's mean.
All right. Well, how about we make it a little easier? Sophie, 3.78 divided by 7.045. Can you do that, Sophie?
Yes.
Okay. And it's also the same thing as 10 to the -8 over 10 squared. This is exactly the same as that. Do you all understand? I'm not expecting you to write it down like this on your homework assignment. I'm doing it so you can see how the thought process goes. So, Sophie, what is 3.78 divided by 7.045 on your calculator? Now you have a reason to use your calculator.
It's a really long. 0.53655074.
Good enough. Let's, when it fills up your calculator screen like this, just take it out 4 decimal places. That'll be all right.
You took it out 5.
Yes, because I thought she was going to stop, but she kept going. All right, so Sophie, what is this?
10 to the negative 10.
Yes, that is right. Good
Whoa, you got it.
You actually got it right.
job.
No,
Are we
that's
done,
not
Sophie?
scientific.
Are we done?
No, because there's a 0 in front of the
That is so right. See, I knew we could teach you. Where's it need to be? Between. Where's it need to be? No, where's the decimal? That's right. There, we're done! It's amazing! A miracle happened. All right, good. So again, this needs to, actually I should probably write this. That number needs to change. We still have 10 to the negative 10. So she says it needs to be between the 5 and the 3, so it's 5.3655, and then we're done.
No.
No.
Times 10.
Why not, Sophie? Because this number's not the same as that one, right?
No.
Well, how do I make this the same as that one?
Multiply by 10.
Oh, excellent.
All right.
Are we done?
No.
Is this number right here, the same as that number?
No.
No. Why? First of all, you didn't tell me what this exponent needs to be. What?
1.
Now, this exponent, this one right here, affects this decimal. So this decimal has to do what to be equal to that?
No.
Which direction? What's left mean?
Negative.
How many
1.
places? Thank you. Now, are we done?
No.
What's that give you?
Negative 11.
Yes. Awesome. Good job. Oh, look at that. There's 4 decimal places. Maybe Mr. Lockwood isn't so dumb.
I
No,
never said you were
I think
dumb.
you're still pretty good.
Okay, so you have 4 different types of problems on here. Do you understand what to do?
Yes. What if you have like something in parentheses, scientific notation in exponent outside the parentheses?
Yeah.
Oh my goodness. Reggie?
Yep.
What number is this?
45.
Give me the problem.
Parentheses, 5 times 10 to the negative 8 power.
The negative what? Sophie was talking.
8 outside parentheses, and then 3 on the outside.
The exponent?
Yeah.
Well, okay, what are you supposed to do with outside exponents?
Distribute.
Like that. Just each exponent on the inside, right? Watch what happens when we do this. That's a 1 there, right? That's an 8, so this is 5 cubed times 10 to the negative 24. What's 5 cubed, people?
125.
Okay, so is that problem done?
No.
Okay, you finished it. I'm not finishing it for you. Anybody else worked on this that you have a question on? Yeah.
What about the, like, number 29? It's like the least to greatest.
Oh, how do you do least to greatest?
Yeah.
A couple different ways. You could make all of your numbers in standard form and look at them and line up your decimals. Or you could notice if all of the exponents are different, they're going to move the decimals a certain amount of places, right? Which makes it easy to see which one's going to have a bigger number and which one isn't. I would say, in until you can really understand what I just said, that last part, I would say put the first couple in standard form and see what's happening until you got a grasp of what's actually happening with the decimals. Yeah, that's a lot of work for you to do, but I don't think it's going to take you guys very long to figure out. I don't really need to take and put this in standard form. I can see.
I know what you mean already.
Okay. All right. All right. Other questions? All right, your assignment, should you choose to do it. If not, you can have the creative shame. Page 515. 3 to 31, 39 to 47.
And combo's almost done. What a lucky duck.